Hello everyone, welcome to this lecture. That is the second lecture on chemical engineering thermodynamics. My name is Varad. I am a doctoral student at the Department of Chemical Engineering, IIT Kanpur. In the previous class, we have seen what is thermodynamics and its motivation, right? So we have also seen about the difference between system surrounding and boundary, and then we also studied about their intercorrelation. Then further, we also studied different types of system, which are like open system, closed system, and isolated system, right? And then at the end we defined the microscopic properties which totally define the system, and these microscopic properties can further be subdivided into two parts. Those are extensive properties and intensive property. So extensive properties are the properties which do depend upon the mass, whereas intensive properties are the properties which do not depend on the mass, right? So in this class, in this second lecture, we are going to study about the various type of state variables, like for example state functions. What are state functions? What are path functions? Then further we are also going to study about different types of processes like isothermal process, adiabatic process, so on and so forth. And then we are also going to study about two most important quantities or properties of the system, that is heat and work, and correlation between them. Okay, so let us start. This is lecture 2 on thermodynamics. Okay, so let us start. So first topic which we are going to study is state of a system and state variables. Okay, state of a system and state variables. Okay, the state of a system means the condition of existence of the system when its macroscopic properties have definite values. If any of the macroscopic properties of the system changes, the state of the system is also said to be changed. Thus, the state of the system is fixed by its macroscopic properties. Okay. So, let us write this down. The state of a system means, so this is first one, the state of a system means the condition of existence, of the system when its macroscopic properties have definite values, right? The second is, if any of the macroscopic properties, macroscopic properties of the system changes, then the state of the system also changes. The state of the system is also said to change. Right? Then thus the state of the system is fixed by macroscopic properties, right? Thus the state of the system is fixed by its macroscopic properties, right? So now the next part which we are going to study is the state variables and path functions or path variables. State variables. Okay, so the measurable properties required to describe the state of the system are called as state properties, right? So the measurable properties required to describe the state of the system are called as state variables. Okay, for example, so we have, for example, temperature, pressure, volume or composition. These are the state properties of the system. It may be noted that for describing a system, it is not necessary to specify all the values of the state variables, right? This is very important. right? So it is to be noted, it may be noted that for describing a system, it is to be, for describing, it is not necessary to specify, it is not necessary to specify all the state variables, all state functions or state variables, right? So for a system, a certain minimum number of variables is sufficient to define its states, because the other variable becomes automatically fixed and have definite values, right? For example, consider a system of an ideal gas. The state of the system may be defined by only 3 variables, such as temperature, pressure and volume. The values of all other variables, such as amount of gas, density, etc., will be definite and can be easily calculated, right? Let us write this down. For any system, a certain minimum number of variables is sufficient to fully define the system, because other state variables automatically gets fixed, right? So the next topic which we are going to study is the state functions. So state function is a property of the system whose value depend only on the state of the system and is independent of the path or manner by which the state is reached. So this is very important, right? So a state function is a property of the system, whose value depends only upon the state of the system, and is independent of the path or manner by which the state is reached, right? The change in the values of these properties, that is state function, depends only upon the initial and final state of the system and not on the path by which the change from initial to final state is brought about. Some common state functions are temperature, pressure, volume, internal energy, enthalpy, entropy, etc., right? So this will also write. So number 2, the change in the value of these properties, that is state functions, depends only upon the initial and final, this is very important, initial and final states of the system, and not on the path by which the change from initial to final states is brought about. So for example, temperature, pressure, enthalpy, entropy, internal energy, etc., these are state functions. Okay, so the next topic which we are going to study about is then there is also a concept of path functions. Okay, so path functions, so these are the properties of the system which depend upon the path which is taken by the system, right? So path functions are the properties of the system which depends on the path followed by system to go from initial to final states. right? And examples of these are heat and or work, etc., right? So we are going to study about heat and work in our subsequent classes. Okay, so the next topic which we are going to study is what is thermodynamic equilibrium, right? So thermodynamic equilibrium, thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium if its macroscopic properties like temperature and pressure do not change with time. The initial state of the system corresponds to the starting state of the system in equilibrium before any type of interactions with the surrounding. In the final state, the system attains equilibrium after interaction with the surrounding. The state function gives the difference in the property of the initial state and the final state. The interaction with the surrounding means the transfer of matter or energy or both. Okay. So let us write this down. So a system is said to be in thermodynamic equilibrium, thermodynamic equilibrium if its macroscopic properties like temperature and pressure or etc. do not change with time, do not change with time and position. Okay, the initial state of the system, the initial state of the system, the initial state of the system corresponds to the system in equilibrium, system in equilibrium before any type of interaction, with the surroundings, whereas in the final state of the system, in the final state, the system attains equilibrium, the system attains equilibrium before any type of interaction, attains equilibrium after interaction with the surrounding, after interaction with the surroundings, right? Then the fourth point is the state function gives the difference in the property, of the initial state and the final state. Like for example, let us assume that this is a graph which is representing pressure and volume of the system. Let's say this is at point 1 is the initial point, and this is the point 2, this is final point, and the system is progressing like this way. So for state function, let us say that state function is for example A. So that state function delta A is going to be AF minus AI. Let's go, this is path 1, this is path 2, so this is going to be AF via path 1, AF via path AI, which is nothing but AF via path 2 minus AI via path 2, right? So it is independent of the path of the system, right? So let us move on to the next topic, which is types of processes. So types of processes. So the state of a thermodynamic system can be changed by a process. In other words, a process gives the path or operation by which a system changes from one state to another. Okay, right? The state of a thermodynamic system, the state of a thermodynamic system can be changed by a process, right? In other words, a process gives the path or operation, by which a system changes from one state to another, right? The process will be accompanied by an exchange of matter or energy between the system and the surrounding. This results in at least one of the state variables of the system. Right? This results in change in at least one of the state variables of the system. There are certain processes in which a particular state variable, right, is kept constant. These are identified with special names. Right? The process may be accompanied. So let us write this down. The process may be accompanied with. The process may be accompanied with. May be accompanied by an exchange of matter and or energy between the system and the surrounding. Between the system and surroundings. Right? This results in change. This results in change in at least one of the state variables of the system. In at least one of the state variables of the system. Okay. So there are certain processes in which a particular state variable is kept constant. And these are identified with special name. And these processes are identified with certain special names. Right? And these are as given in follow. So what we are going to do is we are going to make a table. So it's going to be name of the process and which variable is kept constant. Okay, that's going to be name of the process and state function which is kept constant. Okay, so the first one is isothermal process. Here the temperature is kept constant. Number 2 is isobaric process in which the pressure is kept constant. Number 3 is isochoric process. Here volume is kept constant. Then the fourth one is isenthalpic process. Here enthalpy is kept constant. Right. Number 5th is adiabatic process. This is also called as isentropic process. So why is entropic? Because entropy remains constant here. So entropy is kept constant. Entropy. The symbols are temperature is kept constant, pressure is kept constant, volume is kept constant, enthalpy is kept constant, and entropy is kept constant. Right? Apart from this, we also have another some other set of functions, other set of processes which are. Let me write it down in the next. So these are reversible process, then irreversible processes, and cyclic processes and non-cyclic processes. So let us first read about irreversible process. So number 1, reversible process. Okay, a process in which direction may be reversed at any stage by merely a small change in variable like temperature, pressure. Right? Such a process is called as a reversible process. Therefore, in a reversible process, the driving force is only infinitesimally greater than the opposing force and is carried out infinitesimally slowly. In this process, at every instant, the system remains virtually in a state of equilibrium with the surrounding. Right? Let us write this down. So number 1, so this is a process in which it is a process in which the direction may be reversed at any stage by merely a small change in a variable like temperature, pressure, etc. Right? Therefore, in a reversible process, the driving force is only infinitesimally greater than the opposing force, right? And is carried out infinitesimally smallly, and is carried out infinitesimally slowly, right? In this process, at every instant the system remains at every instant the system remains virtually in a state of equilibrium with the surroundings, right? So the next topic is irreversible processes. So irreversible process, as the name suggests, is exactly opposite to the reversible process. So in this process, the each and every step is not in equilibrium, right? And it does not happen infinitesimally slowly. In fact, it occurs spontaneously, right? So all the spontaneous processes which occur in nature are all irreversible processes, and irreversible processes are you can find everywhere. Like for example, if you have a body at a temperature T1 and you have a body which is at a temperature T2. So if T1 is greater than T2, this spontaneous transfer of heat from body 1 to body 2 happens. So this is an irreversible processes, right? So process which is not reversible is called as an irreversible processes. The driving force in this type of processes is very different than the opposing force, and all natural processes are irreversible, right? So a process which is not reversible, is called as an irreversible process, right? Number 2, the driving force in irreversible processes is very different from the opposing force. These processes happen spontaneously or suddenly, and hence all the natural processes are irreversible, right? The next type of process is, third one is cyclic process, right? Cyclic process. So a process in which the system undergoes a series of changes and ultimately returns to its original state is called as a cyclic process. So a process in which the system undergoes a series of changes and ultimately returns to its original state is called as cyclic process. So for example, let us consider we have a process like this. So let us assume this is a initial, so this represents pressure and volume. So this is the path of the process. Okay, so this is point A, point B, point C, point D. So initially system goes from A to B, then B to C, then C to D, and D to A. So initial and final points are same. So such type of processes are called as cyclic processes. Whereas if I take a system which goes from, let's say, let me draw it in here like this, which goes from, let's say for example, only from A to B, or A to B and B to C, for example. This is A, this is B, this is C, A to B and B to C. So here system does not come back to its initial position, and hence such type of processes are called as non-cyclic processes. Okay, so with this information, let us try to solve an example. So question 1, classify the following as open, closed or isolated system. So this is for what we have studied in our last class, right? So let us try to solve an example. Classify the following as open, closed or isolated system. So number 1, let's for example say thermoflask. So this is whether it's an open system or closed system or isolated system, right? So the correct answer would be it's an isolated system. Why is that? Because let us take for example, this is a thermoflask. So what, it neither allows mass transfer of the system with surrounding, nor it allows heat transfer with the surrounding, right? Hence this is a characteristic of an isolated system. Okay, so now let us move on to the next thing, which is internal energy, right? So this is very important to understand. So we are going to study about different properties of the system now. The first set of property in that is, for example, let us write internal energy. Okay, so what is an internal energy? So every substance possesses a definite quantity of energy which depends upon the factors such as chemical nature of the substance, temperature and pressure, and this is known as intrinsic energy or internal energy and is represented by the symbol U, right? So every substance possesses a definite quantity or definite amount of energy which depends upon the factors such as chemical nature of the substance, temperature and pressure, right? Temperature, pressure, etc., right? This is known as this energy is known as internal energy, right, or intrinsic energy, and is represented by symbol U, right? It is made up of kinetic energy and potential energy of the constituent particles. The kinetic energy arises due to the motion of its particle and includes their translational energy, rotational energy and vibrational energy. The potential energy arises from the different type of interactions between the particles and includes electronic energy, nuclear energy, energy due to intermolecular interactions, and the sum of all this energy stored in the atoms or molecules is called as an internal energy. Okay, so let us write this down. It is made up of kinetic energy and potential energy of the constituent particles right? The kinetic energy arises due to the motion of its particle, right, and includes their translational rotational and vibrational energies. Okay, the potential energy, however, the potential energy, however, arises from the electronic energy, then nuclear energy, energy due to molecular interaction, etc. Nuclear energy, then energy due to molecular interactions, etc. Molecular interactions, etc. Right? The sum of all forms of energy, the sum of all forms of energy stored in atom or molecules, stored in atoms or molecules, is called as internal energy, is called as internal energy. Right? So different substances have different internal energies depending upon the nature of constituent atoms, depending upon the nature of constituent atoms, bonds, and other conditions of temperature and pressure. For example, the internal energy of 1 mole of carbon dioxide will be different from the internal energy of 1 mole of sulfur dioxide, even under the similar conditions of temperature and pressure. Further, the internal energy of 1 mole of water at 300 Kelvin is different than that of 1 mole of water at 310 Kelvin under the same atmospheric pressure. Right? So, different substances, let us write this down. So, different substances have different internal energies, different internal energies depending upon the nature, depending upon the nature of the constituent atoms, nature of the constituent atoms, molecules, atoms or molecules, right, and other conditions of temperature and pressure. Right? For example, this is which point? This is point number 8. For example, what we have is the internal energy, of 1 mole of carbon dioxide will be different from the internal energy of 1 mole of sulfur dioxide, even under the similar conditions, of temperature and pressure. Right? Further, the internal energy of 1 mole of water at 300 Kelvin temperature is different than that of 1 mole of water at 310 Kelvin under the same atmospheric pressure. Right? And we also note that internal energy is a state function. Right? So we will be studying more in detail about why internal energy is called as state function in our next class. So with this we will stop today's class, and what we have learned in this class is we have learned about what is the difference between state variables and state functions and path functions. Further, we also studied about thermodynamic equilibrium. Then we also studied about different types of processes such as isothermal process, adiabatic process, reversible process, irreversible process, so on and so forth. Then at the end we studied about internal energy and the what are its molecular origins and how do we define internal energy. And then we also studied the internal energy of the same substance can be different depending on the conditions of temperature and pressure, and for different substances even under the same conditions of temperature and pressure the internal energy can be different, right. So with this I'll stop this class, and I thank you all for attending this class, and I hope to see you all again in the next class. Thank you.